Hello, this is iMathit with Samuel Oke, and in today's lesson we will be looking into how to obtain the general solution for an homogeneous differential equation. So how do we obtain the general solution for an homogeneous differential equation? Well, what is an homogeneous differential equation? As you can see in all the examples here, all the functions present there are expressed to the same power. Look at sy is to the power of 2, y squared and s squared as well. And in the second one, we have everything expressed to the power of 1, right? So that makes it homogeneous. Well, another thing is it does not contain composed functions such as sine of x or the square root of x. So if a differential equation does not contain composed functions such as sine of x or the square root of x, and it does not have a period of the function y and its derivative, then you say the differential equation is an homogeneous differential equation. So well, let's get right into it. So the first one we have there is xy y prime equals y squared and minus s squared. So what do we do here? So remember, like I said earlier, there shouldn't be a product of y and the derivative of y, the function y and the derivative, which we have here. So let's clean things up a bit by dividing both sides by 2xy so that we can get y prime by itself. So what we want to achieve here is we want to make it homogeneous, although it's homogeneous itself. but we have to clean things up and write things properly. So and we would have y prime equals y all over 2s, because the 2xy reduced the y square, right? And it reduced the s squared to x and all over 2y, right? Okay, and well, that's the first thing. So we get y prime all by itself, so that we don't have a product of it and its derivative. So now we set y equals to vs, and this is the method. This is where the method began. So we set y equals vx. What is the derivative of y prime, with respect to x? So you will notice this is a product function, right? So you say you find the derivative of v and leave x alone, and plus you leave v alone and find the derivative of x, right? It's a product function. So we have v prime and multiplied by x and plus v. The derivative of x with respect to s is 1. So we have v there. Okay. So at this point, we simply go on and replace all this in the differential equation. So let's go on and do that. What is y prime? Y prime is equal to v prime x and plus v, right? Which we just obtained. So this is equal to y. What is y? Y equals vs. So let's put down vx everywhere we see we have y. So we have vx all over 2x and minus x all over 2vx, because y equals vx, right? So, and the x, we get rid of the x there. So we have v prime x plus v equals v all over 2 and minus 1 all over 2v, right? So now you notice we have v all over the place, a lot of v there, right? And just next we put all the v on one side, right? So we subtract v from the left hand side, so we bring it on this side. Let us combine all as one piece on the right hand side. So we have v prime s is equal to let's put in the LCM there. So we have 2v, right? And 2 into v yield a v, and multiplied by v up there we have v squared, right? Next is 2v into v is 1, and multiplied by negative 1 we have negative 1, and 1 into v is 2v, and multiplied by v we have 2v squared, right? So this will be equal to v prime x equals, when we put that together, we have negative v squared, right? And negative 1. And all over 2v. So you notice that at this point, so it's time we express v prime properly, right? So that we can begin separation of the variable. So, well, let us extract the negative component at the numerator there. So like I used to say, it's important to get the negative component out of that v so that we don't run into problems when we are trying to find the derivative, the integral, excuse me. So that is why we factor negative off that, and we put the negative on the left hand side. So we have negative dv dx multiplied by x. Maybe I'm not supposed to write it like this, but let's just leave it. I'm supposed to put that x before dv dx, right? So that it does not look like we are trying to find the derivative of x. So, well, let's leave it. So at this point, we multiplied both sides by dx, right? So we have negative x dv, excuse me, would be equal to v squared plus 1 and all over 2v and multiplied by the v. So this is where separation of variable take place, right? We need to bring all these v variable to the left hand side and bring the s component to the right hand side. To do that, we need to multiply both sides by 2v and divided by negative x and multiplied by v squared plus 1, right? If we do that, we'll be able to get rid of the, we'll be able to separate the variable. So, so this will yield. Please, if you are getting value from this lesson, remember to hit the like button, please. And subscribe to this channel to so that you get more educational content like this. So we have 2v all over v squared plus 1 dv, right, equals, on this side now we'll be having negative x. Negative 1 all over x, right, and multiplied by dx. So it's time we integrate, right? So we simply need to evaluate the integral of both sides to obtain the general solution. So you notice here we have a u substitution type of problem, right? So we set v squared equal to t. Okay, set v squared is equal to t. And what is the differential of t with respect to v? That is going to be 2v, right? So if we have the t dv equals 2v, what is the v? The v would be the t all over 2v, right? Great. So it's time we start to put all this back into the integral so that we can evaluate the integral. So we have 2v all over. Instead of writing v squared, this time we write t and plus 1. And instead of writing the v, we're not supposed to write the v now. So instead of writing the v, we should write the t all over 2v, right? And, okay, this is equal to, let's extract the constant there, which is negative 1, and the integral of 1 all over s is ln of x, and plus c, the constant of integration. Look here, the v cancel the 2v, cancel the 2v that we have up there. So what are we left with? So we now have the integral of 1 all over t plus 1, and the v, and the t, excuse me, equals negative ln of x would be the same as ln of x raised to power negative 1 from indices, right? So we can, from the rule of logarithm. Instead of writing c, I think I should write ln of c, so that the terms can be similar, since the constant itself is a constant, so it can also be ln of c. So the integral of 1 all over t plus 1 is ln of absolute value of t plus 1, and that's equal to ln of 1 all over x and plus ln of c. I hope you agree with that. X raised to power negative 1 is 1 all over x. So we have ln of t plus 1 is equal to, let us combine this. The rule of logarithm states that if you are adding up logarithm like that, so you can take the product, right? So we have ln of c all over x. So I'm going to take the exponent of both sides at this point to get rid of the natural logarithm. So we have t plus 1 equals c all over x, right? So what is t? T is v squared, right? Remember we set t is equal to v squared, right? So t is v squared. I'm bringing this 1 on the other side, so I have c all over x and minus 1, right? So we square root both sides. So at this point, you will notice that our v, what is v? We have y is equal to vs. So v will be equal to y all over x. So I am going to put y all over x anywhere I have v at this point. So we have y raised to power y all over x and raised to power 2 is equal to c all over x and minus 1. Okay, let me distribute the power we have there to both y and x. So we have y squared and all over x squared equals c all over x minus 1. It seems it's not so clear there. Well, so I hope you get that. So we have y squared will be equal to, when we multiply both sides by x raised to power 2. So it reduces c all over s into cx, right? When we multiply both sides by x all over 2. And multiply negative 1 by s squared, we have negative s squared, right? So let me look for a place to write the final answer, because we only have one more line to write now. Let's move the camera. So at this point, we simply take the square root of both sides, right? So we have y is equal to the square root of cx and minus s squared. And that is the general solution to the differential equation. Well, this is the method for solving homogeneous differential equation. And if you are given an initial value, you can go on and evaluate the value of the value of c, and then solve the problem completely. Well, I want you to try the second problem on your own. So, and that will be it. Please, if you are getting value from this lesson, remember to hit the thumbs up and subscribe to this channel for more educational content like this. Well, until next time, keep mathing it and keep winning.